Good evening, everyone. So let's begin with our presentation session. For now, we have only Swastik. Are you ready with the presentation?
Yes, ma'am, I'm ready. Can you hear me?
Yeah, I can hear you.
Sure. I'll just start my video and start my presentation.
Yeah, sure.
Yes, ma'am. I've done my fourth presentation on product demand forecasting. So I'm Swastik Banerjee and I belong to the Department of Machine Learning and Deep Learning. So my task for today was to develop a forecasting uh, collab notebook on inventory data. So I'll start off. So our agenda for today is you can see objectives and then how do we forecast our inventory data. Okay, so we have got sub steps in there. Step one would be pre-processing our data set and optimizing the inventory file that we have. I'll show you right away after this. Next is to calculate all the optimal order quantities for each inventory product. I'll just show you after I finish my agenda. Then these terms will make sense. And step three will be evaluating those solution and finding an optimal solution out of this. And fifth one is key findings, and sixth one is future scope. Okay, so uh, basically what we need to do is that I've downloaded this. It's not opening. Okay, I just have the same thing on Google Colab. So basically what I have is a data set. I couldn't open the actual CSV file, so I'm showing only the first 5 rows over here because it's a very huge file. Okay, as you can see, it has like almost 1 lakh rows in it. So what I've done here is that I've imported it has now I can open it now. So what I have is that I have product codes, I have warehouses, I have product category, date, and order demand. So this is the inventory data that I have with me. So what I need to do over here is to find an optimal solution that is like optimal order demand and optimal reorder demand. What we need to find the best solution for our model basically. So we import the data set first. We notice the shape of the data set, which is like quite huge. It has 5 attributes. Okay, and what I can do after showing you the collab notebook is to go through the first step. Okay, yes. So first step is to pre-process our data set. So first what we do is we import the data set and find the number of rows and columns. Okay, that is the dimension of our given data set using the shape and head function. And then we see the first 5 rows of the data set. That's substep one for you. And number two, what we need to do is to clean our data set. Of course, we know that all the data set that we get are not all clean. There might be missing values in the data set. So what we do is here is use the is null and sum function and then use mode, okay, for date attribute in dataset to carry out missing value imputation. What this means is that what we mean by this is that, as you can see, I have done the is null function and sum function, and date has almost 100,000, 10,000, so 11,000 rows that don't have any date value. So what I do is find the mode value for date, that is the most used date in the whole data set, and I fill those empty values with the mode value. And after this, as you can see, I have no missing values in the data set. So that's how I cleaned the data. Okay. And for the third step, what I do is find the data types. Okay. As you can see, all the attributes has the same data type, which is object, and that is not suitable for us. Date columns must have date type attribute. So what we do is convert the date attribute into date time a type. And also what we do is convert the order demand, which is a numerical column that has to be converted to a numerical data set, right? Data type, right? So what we do is convert the order demand to a numerical data type also. So as you can see, after this operations, we have the perfect combination that we don't have any null values in the data set. And also we have converted our date attribute into date time data type, order demand into integer data type. That's suitable for us. And this is the last step of the first sub step. Okay. I just have to shift between these because I need to show the demo as I'm presenting also. So that is what I'm written over here in the substep 3, that we go on to convert the data at a date attribute column to date time type and order demand column to integer type. And before that, we must see the objectives too. So our main objective is to optimize the inventory data using prescriptive analytics, what I told before. And how do we do that? We calculate the EOQ and the ROP values, which will be coming later in our discussion. We calculate these two values, and these two values are instrumental in determining the optimal inventory data file that we generate. Okay. And after we generate the optimal inventory data file, we evaluate and visualize the solution using appropriate matrices. Okay. So first, we have already pre-processed our data that we got from Kaggle. So second step is the main step, which is generating the OP-INV file. Okay, which is nothing but the uh, inventory file that we generate, the optimized inventory file that we generate, and calculate the optimal order quantity. So what we do over here is first we calculate the EOQ and ROP scores for each row. Then we use 3 different optimization algorithms. Okay, and they are linear programming, integer programming, and mixed integer programming. We'll come to that. Why do we use those 3 algorithms and what are they actually? And when do we need to use LP? When do we need to use IP? When do we need to use MIP? We'll come to that. Okay. And so for substep 2, what we do for each of LP, IP, MIP, we calculate the optimal order quantities for each product. And substep 3 is like we print the cost, revenue, and profit for each of these optimization algorithms. Okay, so I'll just do a demo on this. I'll just show you that how do we calculate the optimized inventory data. Okay, so we have calculated the EOQ value. Okay, which can be derived from this formula. We have calculated the ROP value, which is derived from this formula, and EOQ is nothing but economic order quantity, which is the ideal order quantity that minimizes the total inventory cost. Okay, it is the ideal order quantity that minimizes the total inventory cost by balancing the expenses of holding excess inventory and placing frequent orders. That is EOQ for you. So we calculate the EOQ value for each of the records, and also we calculate the ROP, which is the reorder point for each of the records, which is nothing but the inventory level at which a new order should be initiated to replenish the stocks before it runs out. Okay, so after this execution of this cell, what we get is we skipped 5 or 6 of the data over here because 6 of the records, because it doesn't have efficient data to like get the optimized results for us. So after this, we have calculated the CSV file, which is the same CSV file. We just appended 2 columns after this, which is the optimal order quantity and the optimal reorder point. Okay, and we have calculated values for each of the records, and this is how we generate the optimized inventory file. Okay, so after this, what we do is we just see the optimized inventory file, which has 2 columns added, as you can see, optimal order quantity and optimal reorder point for each of the columns. So I've installed this extension called pulp, okay, we need this while calculating the algorithms, the linear programming algorithms. Okay, so we must talk about LP, IP, and MIP before we go into the evaluation parts. So LP is nothing but linear programming, which is an optimization technique to maximize or minimize a linear objective function. Okay, so when do we use this? Basically, okay, all of them has a like objective function, and all of them have a certain set of constants. Okay, both of them just takes in value from the data set, and they uh, like apply objective functions to them, apply constants to them, so to get the optimized solution. Okay, and LP is used when the decision variables, okay, are continuous. Okay, when the decision variables are continuous, we use LP. Okay, when is IP used? Okay, so is used when we have integer values. Okay, that is whole number rather than continuous values. Okay, so if a data set has fully continuous values, we take LP. If a data set has fully integer values, we take IP. And MIP is the advanced version of both of them, where we have a mix of continuous and integer decision variables, okay, in the same optimization problem. So these are the scenarios where we use LP, IP, and MIP. Although in our case, we have implemented all three of them, and we have tested the net generated profit for three of them. So let's see which one does the best work. Okay, so Pulp is nothing but a library where we can import all the LP sum minimize variable problem um, to calculate in our cell. Okay, so as you can see, it generates it only streamed the truncated the output to 5,000 lines, although it has applied to all of the rows. Okay, so we have got the order quantities for product. This thing is this amount, product 504 is this amount. We got this for each row. Okay, this is applying LP. Okay, and now what we do is we install a package called CBC, which is required to run integer programming. Okay, so so in order to implement IP, we have done the same thing which we did for LP, and we found the optimal objective value for this as well. Okay, for MIP also, mixed integer programming, we also find the same optimal values. Okay, and this is the end of the second step. Okay, as I would say. Okay, that we have successfully generated the optimized inventory file, and we calculate the optimal order quantities for each of these algorithms. Okay, now is the time for testing that which of them has given us the best possible value. So first what we do is what we consider the matrices of cost, revenue, and profit. We'll judge each of them on these three parameters. Although revenue would be the total revenue, cost would be individual cost for IP, LP, and MIP. Profit would be individual, one for IP, one for LP, one for MIP. Okay. So then we observe that MIP algo gives us positive profit. As you would see that after applying all of the algos on the data set that we have, only MIP has given the positive profit. Okay. And then we will use bar and pie chart to visualize the cost versus revenue that we have, the evaluation matrices, and the profit distribution respectively for all three models. We'll see the visualization for bar and pie chart as well. And lastly, the most important metrics that we have is profit. Okay, we'll take the absolute value for all of them, and then we'll compare the net profit that each algo generates. Okay, and then we'll conclude on our key findings from in a report sort of manner. Okay, so what I did is I've calculated the total cost for LP, MIP, for LP, IP, MIP, profit, cost, and revenue. Okay, and as you can see, LP model is incurring a significant loss of approximately 1.76 billion. Okay, the value is really large over here because we have considered like more than 1 lakh records. So it's expected that it would be in billions or trillions, the magnitude of scale. And for IP, what we have is it also incurs a loss. As you can see, the profit is in negative. The IP model is also incurring a loss through, though smaller compared to LP, approximately 114 billion. That's also quite large. Okay, only the MIP model, which is the more advanced model of IP and LP, as the only one generating a profit of approximately 3.93 billion. Okay. We have positive profit for only MIP problem. Okay. Now we'll visualize these things. Okay. In terms of cost versus revenue. Okay. And also the pie chart for profit distribution, only the absolute values. So yes. So we'll visualize this cost versus revenue. As you can see, I've used Matplotlib to visualize the cost versus revenue parameters, where we have categories of LP total cost, IP total cost, MIP total cost, and total revenue. Okay. As you can see that the total cost of LP is the largest, IP is middle, MIP is very less. You just have to like the total cost of achieving the results is the least in case of MIP, and the total revenue is this much, which is like almost. I have the number in the key findings, the number that denotes the total revenue that we have generated, and also we have the profit distribution, which is the absolute values. For LP profit, we have the most. For MIP, it's very less. For 6.1 for IP. Okay, these are the absolute values. So MIP is the least because the absolute values is for MIP is the least. So although it has the only positive value, and diverging bar chart for profit distribution, the same a different basically visualization technique to see the profit distribution. LP is maximum, IP is middle, MIP is very less, almost not not in consideration because it only has the positive profit, and both of them don't have it. Okay, so what we can conclude is that from our report, as you can see, that there are three key findings. Okay, that there are no unique optimal solution. MIP algorithm gave the heuristically the best possible solution. Okay, this is the first findings. The second findings that the total revenue generated came out to be 5,124,597,821. It's a big number. And the MIP model was the only one generating a profit of approximately 3.93 billion. These are the three key findings from the data analysis that I've done on this. Like most, absolutely, I can say that it's a prescriptive analysis on an inventory data management data set. So what are the future scopes that we have? The future scope that we have is we can further use this product demand forecasting model as a base model when we work on productions, scheduling, supply chain management, resource allocation, and many other domains. We can use this data set that I've built, the model that I have built as a base model, okay, to start with. So these are all the references where I took my like inspiration from. Okay, these are all the references. You can see or take a screenshot. So that's the end of my presentation. If you guys have any questions, you can always ask. These are my email and social media handles. You can call me or like email me if you have any doubts. So if any one of you don't have any doubt, I'll just end with my thank you slide.
Okay, Swastik, are you done with your presentation?
Yes, I'm done, ma'am.
Okay. So your presentation was good, and the main important thing, your flow was also good, and the demonstration part was quite clear. That is, I like the most. You explained each point and then transferring it back to presentation and then explaining. That is a very good point. So, do you have any questions you want to ask regarding anything? Um,
No, ma'am, I'm fine. If any one of them in the meeting have any questions for me, I can answer them.
yeah, I guess there is no one going to ask a question.
Okay, fine then.
Okay. So I will provide your scores and feedback on your email.
Yes, I got my scores and feedback for the previous presentation that I did. So
Okay.
yes.
Yeah. So after your review, your presentation, we will provide your scores within 2 or 3 days.
Okay. Sure, ma'am.
Okay.
Thank you. Can I stop sharing?
Yeah, sure. Okay. So next we have Kanchana. You can start your presentation.
Hello, ma'am. Am I audible and visible?
Yes, you're audible as well as visible. We can start.
Okay. So, firstly, my name is Kanchana Daita. I have completed my graduation in Electrical and Electronics Engineering at Jawaharlal Nehru Technological University, National. My domain in this internship was embedded systems and IoT, and this is my task 6. So, the task I have given was sensor interfacing and data acquisition. So, firstly, let's see the contents of this presentation. Let us give it a look on introduction and brief of air quality monitoring system. Actually, we are using this sensor, and the data was acquisited uh, to help these sensors connected into the air quality monitoring system, which helps us to take the input data and to compute it and to get the results. After that, we need to know about the significance and real-time applications, followed by circuit and block diagram, and what are the key sensors used in system, and those explanations. After that, working principle, and what are the types are there in the market, and we need to know about pros and cons, conclusion, and future scope. I'll finalize. So, firstly, introduction. Actually, it is it's an important thing to measure all the contaminants which are present in the air, or the contaminants which are caused by release of any gases, UV rays, or some particulate matter which is present in the air. So knowingly or unknowingly, human body inhales it, but they don't know what they are inhaling in the normal atmosphere also. So apart from natural calamities we have, it is also one of the causes for dangerous health issues like lung issues, cancer problems, etc. Some of these problems may lead to human death also. So for all these things, air quality monitoring is utmost important, which allows the measurement, operation, and predictive analysis of evolution. So that with that we can just identify the diagnosis methods for avoiding all of this. So firstly, let's go to the after introduction, we'll go to the significance. And if we measure it, it is okay. But how we can get after measuring? So user implemented systems are there. So it's like a user friendly systems. So we can just have an Arduino or any microcontroller for computation purposes. Along with we can have an LCD display. So for that, we need to use a 16 by 2 LCD display. Actually, on that, the quality of air will be displayed. For example, it may be good, fair, bad, like that. We can directly have a look on that. Also, there are so many networks into the system. Those we'll get to know in the coming slides. So, what is the significance behind this project? Actually, oxygen is the inhaling air, right? So, in that, what we do is sometimes there will be enriched oxygen, sometimes there will be deficient oxygen. Also, this is utmost important in the hospitals, industries, and some of the research projects, etc. Because based on these only the chemical analysis and all were done. Actually, in the previous days, air quality monitors are used to be non-portable so that they can measure the air quality at only one particular area. And we don't even know how the air will be or how the contaminants in the air will be in other areas if we measure it at one area. So it used to be a difficult task in that days. But as the technology was increased, we now have portable air quality monitors. Also, we have a lot of sensor options also, which sensor to be used for different kind of purposes. We can also choose that and we can opt the particular sensor for a particular application. We can also use the meteorological sensors, noise level meters, etc. actually to detect the particulate matter coming from UV rays also. It is invisible, right? We can't view or we can't even guess how much contaminants are coming out from the UV rays. Ozone also is one of the it's an unwanted thing. So for all those things, it helps a lot. And this is like a example diagram for the air quality monitor. See, it is showing good here. Similarly, it shows according to the air condition. It also shows the temperature, humidity, pressure, etc. parameters. So it is actually one of some of the advantages are it is cheaper and it is most commonly used and it is portable. So people can use it wherever they want, like indoor purposes, outdoor purposes, any projects or for research purposes, etc. It can be used from domestic, starting from a small domestic household through a biggest project also. It can be used anywhere. So it will be based on our requirement, and also the sense of connections and the computations used inside can be varied according to our particular needs. It also has so much of future technological improvements. Like um, it has so many developed it has so many developed features. So from that, we can just opt which type of project we need, which type of gas we need to detect for that kind of application. For example, someone is doing a project on carbon monoxide like that. So if they want to detect the carbon monoxide present in that area, they can use carbon monoxide sensor. Similarly, if we use MQ135 sensor, it measures nitrogen oxide sensor. So it is improved in these days only. In previous days, there used to be a lot of sensors which measures all of these gases. So it used to be a biggest task for them to just validate which of the components they need in between. And some of the real-time applications are smoke detection, particulate matter identification, gas leak identification, indoor and outdoor monitoring, etc. So this is the block diagram we can see. This is the data acquisition block diagram. So this multiplexer is which it computes the data which is taken from the input devices. So input devices may be any transducer. Transducer means it converts electrical into physical components into electrical components, in which we can just due to the signal conditioners. Signal conditioners actually give the multiplexer signals in which multiplexer wants. So this signal conditioner transfers all the data. Like if we have different kinds of data, for example, we have data from UV rays, we have data from carbon monoxide or NO2, we can have data from ozone, etc. So all those components have to be computed at a single time. Also, all those to be um, computed at a single time, and all those to be printed at a time on the LCD of an air quality monitor. So what should we do? We should just give all the data to the transducers. Actually, these transducers are nothing but sensors we use. We get to know how they individually work and how they combinedly work while it comes to the computation in the future slides. Actually, these signal conditioners will just transfer the data is in analog, they convert into digital like that it will do. And after the analog data comes as output from this multiplexer, an A to D converter, which is analog to digital converter, it converts into digital display. Actually, liquid crystal display is in digital format. It displays in a digital format, we all know. So for that, it prints the display on that, like digital display. Also, we can use magnetic tape. We can transmit to any of the device like LCD, laptop, PC, etc. And we can process that. Also, for a processor, we also have Raspberry Pi device. We'll also that. So in these signal conditioners, we can use any of the A to D to A converters like that. And for these transducers, we can use PM2.5 sensor, FQ135 sensor, ozone, VOC sensor, etc. And BME is also one of the type of transducers which can help the temperature, pressure, and humidity detected. So all these combinedly give us output. So what is this multiplexer? Multiplexer doesn't mean only it does multiplication, but it also calculates what are the amount of gases present in the air and segregates each of the amount of the gases. Like for example, it segregates ozone, CO2, NO2, each and every input value it is getting from all these transducers. It segregates and it calculates each and every gas in that particular formula, which has to be calculated in their own way. So after that, we'll get a data into an analog display, and we'll get. Also, if we use MQ135 kind of sensor, we'll get to have digital analog both the outputs. Accordingly, it receives and is transformed, and this gives to the multiplexers. And coming to the circuit diagram, we all know Arduino is one of the most used microcontroller, or one of the most used controller for the computational operations. You can also use 8051 microcontroller or 8257 microcontroller, etc. So this is MQ135 gas sensor. It has uh, it has a bus topology. Also, it works on the principle of identifying gases present in the air. Unwanted gases, like what is the amount of gas you are having. Gases, example, NO2, SO2, carbon dioxide, carbon monoxide, O3, etc. So actually the ground and 5-volt pin are to be given for this. And the A0 is the analog and digital output pin. This pin works only, what we should do before connecting this sensor is, we have to input that sensor as some particular value. For example, 60 is the particular value we have given it. So also we have to give a threshold value. It means 5 or 10%. Let's say 5%. So 5% is the threshold threshold value, that is plus or minus 5%. So if the value in the A, value of particular A is less than or greater than, lesser or greater than that 5% means it will give the output in analog. Or else if it is greater or lesser than 5% means like even that 5% is also crossed. Even it can be a lesser case or greater case. Even that 5% is also crossed means it given a digital output. For that only we will use particular signal conductors, signal conditioners, in which the signal can be transformed into required output or digital or analog from these output of these MQ135 sensors. And coming to BME sensor, BME is one of the most used sensors because it combines a lot of advantages. First thing is it measures all three parameters like temperature, humidity, pressure in the single take. Also, it has a lot of linearity applications, like linear features, and this BME sensor is very cheaper in cost. So coming to this also, it also has bus topology. If it has star topology, what we have to do is we need to connect another device here and we need to send the input transactions from this, like what is the input we are getting about temperature, pressure and humidity. What is the input we are getting? We need to send that input to this device and we need to ask this device that we are sending a data from temperature, humidity and pressure parameters. Are you okay to receive it? Are you like if it is okay to receive it, it will receive the text transmits to the Arduino. This is a complex process, but by using BME sensor, that too it uses a bus topology. We can directly send data to the Arduino without even having any third-party devices. It works. As it works on the bus topology, it also have only 4 points which are similar to a sensor. SCL and SCA are the serial communication linear ports. So those ports will be connected to the A5 and A4 of the Arduino pin. These are all address lines. So for any of the address lines, we can connect these data. And coming to PM2.5 dust and particulate matter sensor. This sensor particularly used for measuring the particulate matter coming from UV rays or sunlight, etc. So these have five pins in major. So 5 volts and ground are usual. Those also have to be connected to the Arduino pin. And RX and TX is the receiver and transmitter pin. So it receives the data from the outside. It transmits the data to the Arduino. These are connected to the TX and RX pins of Arduino similarly. And ground is connected to that. We need to reset this. If, for example, if one operation is completed, like at one area, we have completed the monitoring of air quality. What if we need to monitor it for other place? As these are portable in these days, we can use it anywhere. So if we want to use it once again at the same place, or if you want to use it at another area, what we have to do is we just have to reset it so that any past values or any default values will be totally erased. It starts from the scratch again. So that what happens is even if we have any retained values from the previous operation, it will just delete all of those and it starts working so that the causes of errors will be very less. That is also one of the advantages of this PM2.5. And coming to this Arduino, it has A0 to A8 address lines and D0 to D16 data lines. It has set reset pins, 5 volt input pins, 3.3 volt input pins, green and ground pins everywhere. It also has these TX and RX pins for transmitting and receiving of the data. Yeah. So here we can see, so D0 to D13 are the data lines and similarly A0 to A7 are the 8 address lines and 5 volts reset ground are common for every controller which we use. And reset, as I said, if you want to operate it once again, we just have to connect to the reset pin of the sensor we are using. Similarly, we can use VIN at any purpose of there is stand volts, we can use this. If we have to use like 7 volts or 12 volts or 15 volts, like in DC purposes, we use, right? So in that processes, we can connect those auto transformers to completely step down the voltage to connect that wire to this wheel so that we can have the customized voltage in this wheel. Or else we can directly use 3.3 or 3 volts or 5 volts. Up to this, we can use the 5 volt pin. And the ground pin is similar to the every other microcontroller. These two are the RX and TX receiver and transmitter pins. This is a Raspberry Pi. So this is the second most important component for this measurement. So actually, why this? We need to operate a lot of computations, as I have already said. We can use a processor here. In this processor, we actually program by using the code. We can program this processor. So after that, we can just store the data also. This is a RAM. So in which we can store the data. We can connect this to any of the PC by using the chip connections, see USB to USB 3. So we can use the chip connections. We can, by using cables, we can connect this and we can transfer the data for any of our PC or laptop devices, which we can use for further references or the data storage. So for this power supply, we have USB-C type power supply, and for display, we have micro HDMI port. So this processor is the most powerful one, and it has the code written by us for different kind of applications. We can process it in the different ways, and also for different kind of storages like 2 GB, 4 GB, or 8 GB RAM, we can insert it here. So it will be in the size of a debit card or credit card. That is one of the advantages. And biggest thing it does it does this. It will just operate in every other way. Like it will calculate the data. It will operate as a operate as a monitor, which monitors everything and stores into the data. It operates as a keyboard because we can enter whatever the data we want into this code. So this small size Raspberry Pi is providing us a lot of features. So this is one of the most important components for this kind of applications. And this is PM 2.5 sensor. This is MQ135 sensor. So we'll just know in detail about this in the document I have made. This is BME or BMP 280 sensor. So let us go to the document. Yeah. So in the document, what are the list of contents in the document is, again, we have a brief information on about the sensor. What is the significance of using these kind of sensors only? And the block diagram of actually what are the sensors have to be used for project, explanation about them and how they work. What is the code and simulation by using that sensor? And what are the types of air quality monitors used are made by using these sensors? So firstly, and the introduction and the significance we have already seen in the presentation. This is also the similar block diagram as we have seen. We can have a lot of sensors here as the input devices and multiplexer as audio UNO R3 and AD converter. After that, the LCD 16:2 liquid crystal display. The circuit diagram also stands the same. Now key components, as we have already seen, Arduino UNO R3, MQ135 sensor, PMS 5003 PM2.5 sensor, Raspberry Pi BME sensor, connecting wires, LCD display, and a software system used for simulation. So this is Arduino UNO R3. So we can use any of the microcontroller like 8051 or something else, but Arduino UNO R3 is standardly used and this is the most popular controller, so that we have used it. And it also has one of the advantages that at the pin A0, it has a buzzer. So it will beep if the, like we can also provide it operations. For example, we can provide operations such as like I have already said the example. If the condition we have given is 60. So if the particular gas is less than or greater than 60, if it is less than 60, it is okay. So that it will just provide a beep sound which resembles that the condition you have given is true. If it doesn't give a beep sound, means the condition you have given is false. It is an indication from that. So what are the specifications we can use? The input voltage, as we have already said, 7 to 12 volts is the input voltage and 20 volts is the limited voltage. Above that we can't use for the DC applications. And digital input output pins are totally 54 and analog pins are 16. The DC current we can use is up to 40 milliamps, and for any of the input voltages like other than 3.3 we can use the 40 milliamperes, but for 3.3 volts we can use 50 milliamperes. There is a memory in this which stores the data for the computation. So that is 256 KB. Standard RAM will be static RAM will be 8 KB. Electrically erasable programmable read-only memory will be of 4 KB. So the clock speed is 16 megahertz. So for one cycle, there is 60 mega for 1 second. There are 16 megahertz cycles are going. Like at that cycles per second, 16 mega cycles per second are moving for 1 second. That is the frequency handled by Arduino UNO R3. Similarly, as I have already said, it is a full-fledged PC which operates all the computations which we can use in PC at a very low cost, and it has already it is interoperable so that we can use it any output or hardware applications, software applications, etc. in effective ways. So it is also a system on chip application. Any of the versions can be used, but we can use 4x ARM Cortex version, and the RAM is up to 1 GB As we have already said, there are so many options for storage purpose. We can use broadcast video for general processing unit for this, and the Bluetooth is 4.1 classic version. It has a micro uh, SD card in which we can use to store the memory. Also, the general purpose input outputs are 40 pin headers, and the ports are HDMI 3.5 analog type. Yeah. So now in detail, we need to know about what are the sensors we need. This is the main concept. So actually, the core concept of this task is to identify what are the sensors used in this project and what are the how the data is executed from them. So firstly, as I have already said, this PM2.5 sensor is used for identifying the particulate matter which is released from UV rays, sunlight, or the any of the like natural calamities also. So this is actually developed for monitoring and measuring the quality of air, indoor air or outdoor air. Actually, particulate matter is one of the dangerous pollutants for a human body. So if we doesn't identify that things, as I have already said, we may have oxygen efficient areas, oxygen deficient areas, or enriched areas. Because of the small size also, the particulates can be penetrated deeply into the human lungs. So it may cause into it may take severe actions on the human life. It also takes human life to death if we leave it for over a longer period. So it can cause asthma or any lung cancers, etc. So a long-term damage to the people health it can be caused, which is caused by air pollution, can be prevented if the sensor is used in some vehicles or any outward applications, etc. So how it is designed and what is its function? So it is designed to have a detection chamber into it. It looks like in a small size, but it has a detection chamber in it, in which whenever the suspended air particles are flowing through it, it will just identify what are the type of particles it is, like what is the range of those particles is. It sends the data into the Arduino type. It will just recollect the code what we have done, and from all the input values, it will just compute and output is given from that along with all the other sensors, it will just compute it and output will be given. So actually, uh, we put this sensor where the air is stuck actually. So where the air is stuck, if you put in the air, like if you put in the outside atmosphere, it can work. Also, if the air is to be drawn in elsewhere in the chamber, it will just intake that air and it exhausts after the process. So it can be arranged by any of the companies. Hala is one of the most companies which will be like these sensors are manufactured or provided, and it detects and counts the particles also, like how many light scattered particles are flowing into the chamber. Also, what is the light receiving by the there are diodes and all into the construction of the PM2.5 sensor. So how the scattered light is that is identified by the diode. Also, it will recirculate into the align interface. It will give additional features such as automatic air recirculation or filter surface of the particulated air into the purified air, etc. So it can be worked as a welcome side effect also. Vehicle operating costs or any other operating costs can be reduced by filtering these, because already if it is filtered means we can there is no need of using any other filters, right? So that is one of the significant uses of it. And how it interfaces with Arduino. As we have said in the seen in the circuit diagram, we just need four connections. The pin 1 of VCC should be connected to the Arduino 5-volt pin, and ground pin of like pin 2 of this is ground. So that will be connected to the ground of Arduino. And UART pin, that is fourth pin and fifth pin. RX and TX, which are receiver and transmitter, as will be connected to the third and fourth pins of Arduino. So yeah, this is the diagram how it works. So firstly, there is an inlet, as we have said. Actually, it is a chamber, but if we have a detailed view into the chamber, it will be like this. So this is the airflow channel. So this is the inlet. There will be a photodiode. It will just absorb the light scatterings if there are. So after this light scattering, by using this photodiode, the light will be trapped here. So after this, it will recirculate it so that there are some fans here. So by those, it will recirculate it and the outlet purified air is released here. At this light trap only, we can detect how much, what are the contaminants present in the scattered light. And there are also some specifications for this sensor. The size has to be in the volume of 53 by 40 by 51 mm, and the weight should be like this. This can also stand as an example for threshold value can be 53 grams plus or minus 7 grams can be variation given. And sensing range, it has to be utmost sensitivity should be maintained, because if even a single 0.01 difference is same, means the whole Arduino will just operate assuming that is the correct value. So whole Arduino program will assume that that error value is a true value, because the machine doesn't know until and unless a human programs it. So as they have programmed it and as the sensor works it accordingly, even if they have any error, until the output comes, we also can't assume that, oh, there is an error coming or it is perfect, we can't see. So we have to select, like while arranging the sensor in the circuit, we need to be sure that the sensitivity of that is highly proper. And coming to power consumption, it will maximum consume around 1 watt, and noise released by this is 38 decibels. The second one is CO2 sensor, like MHZ19. The version of the sensor is MHZ19. It is mainly used for measuring carbon dioxide. See, actually, carbon dioxide causes problems in the respiration. Also, it is as it is exhaled by the human, it also like causes problems by in the respirational way. Also, it can be attacked from the direct light focuses that a human faces. It can be one side input of the beam in the circuit, and the other side it gives infrared radiation. You can see in the circuit diagram. So this working principle, like infrared radiation sensor working principle, is which is filled with air. So in this, what we can do is we can put an optical fiber. So that optical fiber or an IR detector, which measures the amount of IR light coming from that. So when IR light is passing through that optical fiber, it detects how many CO2 gas molecules are there present in the air, so that we can get a specific band of IR light, like some bandwidth of an IR light in which the CO2 gases are passing. So from that we can conclude how much carbon dioxide gases or molecules are passing through the optical fiber. So it is quite accurate because there is only one device in between as the sensor is having. There is no much complexity in this circuit. So it gives accurate results. See, here we get infrared light source, and after that we can have IR detector. So this is an optical fiber placed. So when the light is passing through this optical fiber, the IR detector detects what is the amount of carbon dioxide molecules present in the air. This is a simple chamber. We can use any of those shapes, and this is the outlet. After IR detection, the outlet will be like this. And it also has some specifications. The CO2 sensor has two types of sensors. One is Z14 and the other one is Z19. There are two like very small differences between those two. The difference is that analog output. So analog output will be in the uh, like analog output will be in the complementary action of the digital output. That's why we have star here. But here we have 0 to 2.5 volts and 0.4 to 2 volts. But in the digital way, we can have the complementary action of V naught what we have got. So it also works on the pulse width modulation in the both devices. The history operation will be done in both devices. The V positive, V negative. Similarly, V in will be given to the input of this MHZ19 and ground, which is taken as 0 volts for for MHZ14 and for this MHZ19. And RX and TX pins are same for anything, but just we denote with R and T here. These are the Arduino pins. For these pins, we need to connect these two. And like if we have to connect to the Arduino, what is the specification we need is observed. And third one is VOC and ozone sensor. So these VOC and ozone sensors are used to measure gases. Like gases means it can be any gases like ammonia, alcohol, benzene, or any nitrogen oxide, sulfur oxide, etc. So it works based on detecting the change in resistance. So we have different principles acted for different sensors. What is the most used or most popular or most efficient method of principle is taken and explained here. So let's take an example of ozone. So in a normal household also, ozone can be generated by air purifiers like facial steamers, like germicidal lamps, etc. So even we all know UV rays cause UV rays generate ozone. So for that, this sensor is responsible for detecting those ozone type of gases along with ammonia, alcohol, etc. It contains two electronic devices to interface with a microcontroller. It also has a better feature that it has two analog outputs, and one is a analog and one is digital. Two outputs it has. As we have already said, MQ135 is the true output based on threshold value and based on the performance of the gases present in the air. It will give you the result. If it is less than the threshold value or equal to the threshold value we have, it will just give analog output or else it will give digital output. This is the simple view of an MQ135 sensor. So how it works means it has a sensing material here. So actually we have a resistance, standard resistance here. So if it is in the middle of these target resistances, like if it stays between these two resistances, it will generate output. If it is not staying in that resistance space, it will give digital output. Let's see the working principle in even more detail way. Yeah. So in the MQ135 sensor, we'll just place a sensing element. The sensing element is nothing but any current coil like that. So whenever the current passes through the coil, obviously resistance changes. So whenever those resistance values are changing, the element alters the value of the current going, right? So resistance is which um, obstructs the flow of current. So whenever the resistance is changing, the current will be obviously decreased. So the heat generated by the increment of resistance is observed at the contact length of the sensing element. So from that, we can say how much resistance is changing. Accordingly, how much gas flow is there from the releasing of those heat molecules. And what are the connections of sensors to the Arduino? From the left to right pins, we can see analog output, digital output, both should be connected. There are only 4 connections here, very simple. So we can see. So here analog output and digital output should be connected to these 2 pins. And these 2 are V and ground pins, which is 5 volts V in input voltage and ground means negative 0 volts. It also has a specification. It has 2 waves, low concentration and high concentration. As we have already said, 2 concentrations depends upon threshold values. So it will have detection range from 10 to 10 to 1000 parts per volt, and it also has sensor ranges. So if the sensor is like, we need to denote the lower voltage by VL and higher voltage by VH. Here also we can see VL and VH and load resistance, heater resistance. See, as the resistance is occurring by the flowing of current, we can have those resistance as a different denotion. Because already the load is having some resistance, the sensing coil which has inbuilt resistance. So that resistance are taken as heater resistance, but what the extra resistance that is getting is considered as the load resistance. And what is the heater consumption? That is calculated as some 1000 milliwatts. And what are the load conditions? We need to have sensitivity, output voltage. These are all the load conditions in which load can be altered based on these. Yeah. So there is an example code in which we can just set the input mode. So in the sensor value and digital value, we have to just give the input in the what are all the pins we are using. So 13 is the output pin, 3 is the input pin. So we are instructing the device that 13 is the output pin and 3 is the input pin. So we already know that void loop is the basic program that an Arduino need to have. And here see, there is a simple conditional statement we are using, that those are equal. So if the sensor value is greater than 400, it writes on its digital board as at 13 pin, it is high because 13 is output pin. Else, if it is low, it will write at the 13 pin as low. This is a simple value. And also, after one computation, we'll have 1000 milliseconds as the delay because we need to have the difference, no? So what is after one operation, we need to, it also needs to get a delay about for 1000 milliseconds at least, because to continue for the next operation. So here also 100 or 1000 milliseconds, it will wait for the next event. So this is the code we can implement to get the MQ135 sensor work. And the final sensor is BME280 sensor. So this BME280 sensor measures all three parameters together, such as temperature, humidity, and pressure. Firstly, this is an atmospheric sensor. It is developed on a single chip, and it has SMD resistors, SMD capacitors on the SoC, and it is developed by the Bosch company. It names as BMP or BME280, usually called as BME280 sensor. It has a technology that is single technology that can all measure the temperature, pressure, humidity in the single take. As I have already said, it has so many advantages like linearity and low weight. So it measures pressure by taking the advantage of piezoelectric properties. So piezoelectric properties. As I have already said, it also have a coil in it. So whenever it needs to measure the gas, it will just insert the coil. Like after insertion of the coil into the device, we can know how much current is flowing into it. After the current flow, the resistance obviously changes. So that resistance values are or the mechanical load along with the mechanical load are provided to the Raspberry Pi board, similarly to the Arduino for the computation. So whenever the output block is given in the output block is given to this BME sensor, it just measure by it just measure the degree of the gas it is having. So by that we can have temperature. So the pressure temperature are calculated. As it measures the barometric pressure, it also measures the humidity by estimating the altitude in the current atmosphere. So there are several versions in this module. We can use any of the communication protocols such as inter-integrated circuits, serial parallel intercommunication protocols, etc. to exchange the data. As I have said, this works on the bus topology. There is no need of any third-party device here. We can directly use I2C port, which also works on bus topology, and exchange serial communication, which also works on bus topology. It has a microcontroller with that, so with that it can exchange the value. Also, we can use the Arduino or any 8051 in the place of that microcontroller. And if we use I2C communication protocol, the pin configuration we have to do is beam we have to give for 5 volts, ground we have to give for ground, SCL is for A5 and SJ is for A4. This we have already seen in the circuit diagram and block diagram. So how it measures the pressure, temperature, and humidity, like how it reads. So there is an algorithm in which it follows. Firstly, we have to bring these inbuilt libraries such as adaptive sensor and adaptive BME 280 library. These interface with the sensor automatically whenever we uh, include these inbuilt libraries. And after that, we need to create a variable called sea level pressure underscore HPA. So at different, for example, if we are measuring it at sea level, we can use that. Or else we can, according to the area, we can use we can use it. And this is based on I2C communication protocol. After that, we can create an object like adaptive underscore BME 280. So in the as you are using serial communication, it will set a bar. After that, in the loop, we can print the values accordingly. Similar to the MQ135 sensor, we can print it less than or greater than like by using conditional statements. We can print the results in the serial monitor. This is the diagram which we have already seen in the circuit. And there are some temperature sensor specifications. Like operating range should be 65 to 85 degrees centigrade. It is measured in degrees centigrade as is temperature. And supply current should be up to 1100 microamperes, and absolute accuracy temperature should be plus or minus, it should be like plus or minus 1 to 1.5 degrees Celsius when compared to 65 to 85 degrees Celsius. And resolution should be very low. That should be just 0.01. And RMS noise levels also should be very low because as it has the lowest oversampling, it should have minimum noise, right? So it has 0.05 degrees Celsius. Yeah. So we have seen all the different sensors which can use the data. So the first half of our task is completed. Now the second half, how the data is acquisited from all of those sensors. So as we have seen, MQ135 sensor is a gas sensor. It just gives the gases such as NO3, alcohol, NOx, benzene, carbon monoxide, ozone, etc. Now, for a particular project like air quality monitoring or air quality detecting or gas leak identification, smoke sensing, etc., for any of these projects, these measurement of these gases is utmost important. So after the measurement of this, like whenever we want to measure these gases, we'll just connect it to the Arduino, and whenever this senses the gases, we'll get the pollution level in parts per million. So that is the action of this MQ135 sensor. And what are the other sensors we have? We have BME sensor. So similarly, whenever we want to measure a data, uh, we just connect it to the Arduino boards like SGL, SGA pins. After that, whenever the change in resistance happens in the air, happens in the current flow in the current coil, in the sensing coil, it will just transfer that data to the Arduino board. Similarly, if we have the value of particulate matter, again, if you want to connect those reset and RX and TX pins to the Arduino board, which will connect 4 and 5 pins, that will be given to the VN and ground pins of the PM 2.5 along with Arduino. It will also measure and it will be also computed to the Arduino. Similar action takes with VOC and carbon dioxide sensors. So for all these sensors, it stays the same. In the MQ135 sensor, it uses a particular library as we have already seen. So if it is given valued as 90 and no gap is safer at a level of 350 pm, 350 ppm, we should mention it that it should not exceed 1000. So that if it exceeds means it will show us the digital output. If it is less than the 1000 ppm parts per million means it will show the fresh air or analog output. So if it is lesser the 1000 means it will display fresh air and buzzer will start beeping. Why the buzzer will start beeping means we have already given the condition. If it is lesser than 1000, that condition, please deliver that condition is true. So as we have seen, the condition is true. In the first slide, we have seen that Arduino will beep a buzzer at the pin A naught if the condition is true. Similarly, if the condition is true, it will just give the 1000 ppm. Will give it is less than the 1000 ppm. It will display flash. Also, it will buzzer. But if we increase that, like for example, if we have 2000 as a value, then it will display like danger, move to the fresh air. So these are some of the instructions or indications provided by the air quality monitor. For example, this is the serial communication which we have like I2C or any SPI. It will read CO2, it will read particulate matter, it will read VOC, it will read ozone, it will read temperature, humidity, pressure. All those will be given to the particulate parameters, particular variables of the Arduino. So CO2 variable, PM2.5 variable, VOC variable, O3 variable, temperature variable, humidity variable, pressure variable, all the variables are connected here. So whatever the gases are present here, those will be computed by the code we are given to the Arduino, and it will work and it will just convert into the digital by using AD converter we have seen in the block diagram, and the output is displayed. So this is the final working principle of the Arduino. So in this way, we can acquisite the data. So we have seen how the sensors can work and how the data can be acquisited. So sensors and data acquisition is our title. So I think I have justified the title, like I have explained how the sensors are used and how the data should be acquisited from the input taken from the sensor. So how the general air quality monitoring works? As it collects all the samples from all the sensors, it computes in its own way, like by scattering method, LSR method, gases on NDIR method, electrochemical sensing, photoionization, etc. In these ways, there are so many methods of working, so those are the ways. So here I have written uh, like it's like a case study. So what happens in which case? See, for example, as we have already given the void loop in the Arduino, as I have previously mentioned, we need to give a void loop for an Arduino. After that, we can just use it like if it is less than 181, you will display good, it is good. Else if it is greater than 181, you will display poor. If it is greater than 225, you display very bad. If it is greater than 300, you will display you are dead. And it is not at all staying in all these values, it will display false. So this is an example idea we can have. In this way only, we will write a code to the Arduino. After getting all the parameters from the all sensors we have used, we will get the final conclusion by knowing which gas is working or whatever the air quality is there. So just by looking at the LCD display, we can have an idea is it good, poor, very bad, or go to an fresh air area. This is dangerous. Like that, it will show the instructions. And this is a simulation diagram. So here is the LCD display. So it will display whatever the sensors are there. This is the Arduino board. This is PM2.5 sensor. This is MQ135 sensor. Sorry, this is MQ135 sensor, and this is DME 280 sensor. Yeah. So until now we have known how the sensors are working and like how to connect the sensors and how to get the data out from the sensors and how to get the LCD display output on the LCD display after computing the system. So what if our operation is wrong? For example, we have used it in a project. For example, we are doing a project, like some researchers are doing a project. So how can they know whether their results are correct or not? Or a domestic purpose also. Suppose any gas leaks are happening, we can't even imagine how the situation will turn out, will turn into if they're happening like any gas leaks or something else. So how we can test the system if we want to use the system in the immediate requirement. So there are several ways to test the system. One is testing at normal age. Other one is testing at MQ7 age, and the other one is MQ135 sensor testing. So these three methods helps us to make the system even more efficient by testing that in the different conditions. So firstly, at the normal age, we'll not even pollute the air by any cigarette smoke or any gas smoke, etc. We just leave system as it is, the atmosphere as it is, and then we'll perform the testing. And system using NQ135. System using NQ135 will be just, it's done in the indoor air quality monitor. For example, in the indoor purposes, we'll do. So it can be seen, we can burn the wood or we can release any gases. So from that, it will measure what are the levels of carbon monoxide in the area. So that can be done as a test. And we can use a small LED, small rated LEDs to get the output. We can use small rated values in the testing purposes because we are testing them only for an reference purposes. They are not the original testing, right? So there is no need of investing more on this. We can just use small rating testers like that. And after that, if the LED is indicating green in the MQ135 sensor, it is good. If the LED is indicating red, it indicates that air quality is polluted. If we use LCD, we can have a detailed explanation. The air quality is good, temperature is like this, pressure is like this. But here we are testing for only our domestic purposes or any small projects. It is okay to use an LED. It is okay to have the two kinds of LED which will glow green and red according to the data provided in the sensor. And last one is MQ135 sensor. So from the above two results, like from the MQ7 and the normal rate testing, we can have an idea that CO2 level in the cigarette is 235 ppm because as we have tested, we can just have an idea, rough idea that 235 parts per million is the having carbon dioxide level in the cigarette smoke. So for that kind of cigarette smoke or any paper burning smoke, we got CO2 released. So that CO2 can be measured by using this MQ135 sensor. As I have already said, MQ135 sensor is used for measuring gases. We can use that. Okay. So what are the different types of air quality monitors we have? See, if we want to know how the sensors are working, how the data is executed from that sensor, like how to extract the data, how to calculate the data, how the code has to be written and inserted into it, and how the simulation is worked. We have seen everything here. So what if someone wants to know what are the different types of air quality monitors by using that all those sensors? So according to the different kinds of sensors used and according to the application of use, these are categorized into three types. One is lab grade, another one is commercial grade, and the other one is consumer grade. Lab grade is the most highly costed air quality monitors. Those are used like very high rated sensors and very expensive sensors are used so that the researchers or any government authorized like who have licenses only can be those who have licenses they only have right to buy those monitors. So that is the case in the lab grade monitors. And the commercial grade monitors are again classified into three types: outdoor air quality monitor, indoor air quality monitor, and interior air quality monitor. So let's have a look into lab grade first. Lab grade, as I have already said, there's a very mass production in the single take, and those are to be used only by the government or any authorized scientists to measure the air quality. As they are so much accurate, so much linear, there will be no like issues of sensitivity, resolution, or precision. They can be used in the lab and research purposes, which will give the accurate values. Like if there is not even a single error in this kind of application. So for that purposes only, it costs a little bit high, and also it will be non-portable too sometimes. And coming to consumer grade is total opposite. It stands totally opposite to the lab grade monitors. It can be used by anyone. It can be used in both indoor and outdoor applications, and it also helps to increase the HVAC efficiency too. So we can see the HVAC efficiency in the air quality monitors. So these are cheaper and portable, which are non-portable and expensive in the lab grade. This is opposite, cheaper and portable. This can be used in indoor and personal uses also. It also costs very low, and the operation is also very like non-complex, so that even for a domestic household can also it can be helpful. And commercial grade monitors, it is big difference. So it stands between both lab grade and consumer grade. It can be used for small researchers or any hospital or like any small scale industry applications for that they can be used. So this has two versions, Sensors and Sensors Mini. So these are the primary use building projects or for providing certifications. These are used. Again, these are classified into three types: outdoor, inductor, and interior. So outdoor air quality monitors it will gather the ambient air quality data. So whatever the data is, it will just calculate and it will gather, and it will just it can be useful for outdoors, like for particulate matter, ozone. It's not like a it will be used for outdoor purposes also. It also used to measure the maximize the HVAC efficiency. Whereas index monitors are similar to the interior, like this can be used only in the interior purposes. But these index monitors also maximize HVAC efficiency a lot. Heating, ventilating, air conditioning efficiency will be so much improvised. Why? Because we are measuring the air quality inside a room, inside the interior area. So if the interior area air is totally good in its quality means, obviously the ventilated area or the air conditioning system will be at its top level. So for that, in maximizing those efficiencies, we can use air monitors as an example or any application. In the interior monitors are used for building projects, as I have already said, for using building certifications or to outdoor pollutants, like not in a higher range or higher levels, but for smaller levels, we can use for both in the interior and outdoor purposes also. It will also measure the carbon dioxide and PVOC for outdoor pollutants. It can also measure the humidity and temperature. So with this, our main core content, that is how the sensors, like our topic is sensors and data acquisition, how the sensors are worked and how the data is extracted from the operation of the sensors we see. Now let us switch to the presentation again. So now here we'll get to see the prototype connections. As we have already said, what are the pins to connect in each and every component to the Arduino. So in a similar way, these are the three sensors we are using. This is a liquid crystal display. This is the Arduino board. For each of the board, we need to connect by using the ports, we can connect the data. So in this, there are several port subsystems in the design of circuit of the Arduino board. There are several subsystems. So in the several subsystems, it will be classified into different colored wires. So for input data, we can have green, or at ground we have black, and for negative we have red, like that. So for a particular different sensor, we can just identify what is the color port we need to use, and for accurately we need to connect the data. So this is the pin configuration. So again, I'm giving you like for what sensor, how we should connect. Like for VCC or VSS of an LM35, you need to connect the 5 volts. So for V out, we need to connect the A naught because it buzzes the value according to the output value. And for ground, you need to connect the ground. Similarly, in MQ7 and MQ135, it stays the same. The VCC stands for 5 volts and here also it's for 5 volts. Ground is to be connected to ground. Analog output and digital output are there for MQ135, like gas sensors, right? So for that, for MQ7, it stands only analog output, and for MQ135, it stands for like analog output 2 because it has two versions of output. So input is obviously provided in the two versions. And LED also. If we use LED in the place of LCD for small purposes, we can use 4 LEDs. In the 4 LEDs also, we can use 2 greens and 2 reds. So if the 2 greens are giving you positive in the positive value in the register and negative value, those are to be connected to the second and fourth pins. And 2 red LEDs are connected to the negative value of the register, so should be connected to the 3 and 5 pins. And all the ground pins are connected to the negatives of the LEDs. Next is what are the pros, cons, and examples of this project. So one of the after looking totally into this project, we can surely say that there are so many advantages in this project because we can concentrate on protecting the public health. We can concentrate on ensuring the efficient gases. We can concentrate on ensuring the oxygen enrichment, etc. And even if there are any deficiencies in the oxygen or carbon monoxide levels in the environment, we can just give the proper diagnosis, or we can just properly research about that to give the exact solution for that. So not only not only domestic households and normal students can do this, but also for research scientists or any project builders for building certifications for any of these or any hospital applications industries. Not only small scale industries, but very large scale industries are also using these air quality monitors. So for all those kind of applications, these are being used. It also can be used in schools. So to ensure that students are inhaling the proper oxygen and all. So these are all the kind of advantages in this. So what are the disadvantages? One of the biggest disadvantages is suffers from little cross sensitivities. What are cross sensitivities? It should not have any differences in this measurement. Second thing is it should be so accurate so that any other kind of error values can take place. And third one, it will be affected by the external factors, like as they are exposed by the atmosphere, we are using them in both outdoor and indoor conditions. They are exposed by different dust, smoke, or any other particles that fall on the mission, so that it can be. It used to get maintained every day. Like every day, we need to do some maintenance for that. So it would be a little bit difficult task for the user. So that may be caused as a disadvantage for this. Also, for some kind of applications, it is expensive. As I said, lab grade monitors are quite expensive. And coming to the examples, as we have already seen the real-time examples, applications, these are examples. So many examples are there for air quality monitoring systems. One of those are constant emission air quality monitors, continuous optimize air quality monitors, manual inspections, etc. So what is the conclusion and feature scope for this project? We can conclude that we have seen both hardware and software connections of an Arduino of all the sensors. So the total air quality monitor prototype, how the sensors are working, how the data should be acquisited from that. We have concluded in both hardware and software solutions. Also, we can collect the data by using all those different sensors, and we can connect to the Arduino, we can compute it, and we can get the output from those AD converters. So these are all the things we have seen. And what is the future scope? Not only by using an Arduino or not only by using these MQ, PM or any PME sensors, we can use a GPS module in this. We can use any different kind of age sensors, light sensors in this. In the future also, along with the growing technology, we can also have even more efficient methods to execute these operations. So in the real-time applications, we can measure air quality, we can detect the air pollution, etc. The known applications, there are constant applications for it. But in future also, for different kind of sensors, we can have a different kind of application accordingly. So that will be even more efficient for the researchers or scientists who make projects regarding these kind of domains. So these are the references that I have used for this project, and this is my contact and email ID. So if you have any questions, thank you so much for providing this opportunity.
Okay, Kanchana, are you done with your presentation?
Yeah, ma'am. I'm done.
Okay, so as always, you gave a detailed presentation, like your documentation plus your presentation part. So can you tell me that what is the sample rate of data acquisition system?
Yeah, ma'am. Sample rate will actually depend upon different kind of gases, ma'am.
For example, any example you can relate? Yeah, in simple terms, what do you refer by sample rate? Yeah, how you will calculate it?
Sample rate means, yeah. Okay, ma'am. So sample rate means for 1 second, how many samples of that gases are passing into the sensor. As we have seen in the PM 2.5 sensor, it has a detection chamber. So in the detection chamber, for 1 second, how many light molecules are passing through it? Similarly, if we take MQ135 sensor, we have used the resistance for measuring the data in that. So in that resistance, how many what is the ohms value of resistance units is passing through the current coil. So accordingly, the sample rate can be decided. It will be depend upon the practical application we have.
Okay, fine, perfect. Rest, your presentation was totally good from my side. Do you have any questions?
No, ma'am.
Okay, so I will provide a response and feedback on your email.
Okay, ma'am. Thank you so much.
Welcome. Okay, so we are not left with any more interns, so we wrap up our session. Thank you so much, everyone.